Chapter 6, Lesson 3 of Geometry, and in this lesson we want to take a look at proving that a quadrilateral is a parallelogram. And we want to do this by using what we learned in Lesson 6.2 and using the converse to prove that these parallelograms, or that these quadrilaterals are parallelograms. So the question is the four-sided figure we're looking at a parallelogram? Now, we did go through a classification process and we asked certain questions in that first lesson. We asked, are the two pairs of opposite sides parallel? And based upon that, we classified it as a parallelogram. Then we took a look at these parallelograms and certain characteristics that were true, and basically they were in the form of theorems. If the figure is a parallelogram, then both pairs of opposite sides were congruent. If the figure is a parallelogram, then both pairs of opposite angles were congruent. If the figure is a parallelogram, then both of the diagonals bisect each other. And those were what we learned in Lesson 6.2. Well, you remember when we have if-then statements or conditional statements, we can write the converse by switching the conclusion with the hypothesis. And if the original theorem is a good definition, which all theorems are, then the converses will also be true. So in this lesson then, if we can show any of these three things that we learned in Lesson 6.2 to be true, then the figure must be a parallelogram. So as we're looking at a diagram, if we can show that both diagonals bisect each other, then we know we have a parallelogram. Or if we can show that both pairs of opposite angles are congruent, then we have a parallelogram. Or if we can show that both pairs of opposite sides are congruent, then we know we have a parallelogram. So using the converse of these, we can determine whether a four-sided figure is a parallelogram. So we're simply doing the converse of what we learned in Lesson 6.2. There is one additional method that we could use to determine whether a four-sided figure is a parallelogram. And that is this. If you look at one pair of opposite sides, just one pair, and those opposite sides are both equal in length and parallel to each other, then the four-sided figure is also a parallelogram. So you have an additional way that you can use to show that a figure is a parallelogram by looking at one pair of opposite sides. And if it meets the condition that those opposite sides that you're looking at are both parallel to each other and congruent to each other, then you can conclude that that figure is a parallelogram. So not only do we have the three converses from the theorems that we learned in Lesson 6.2, we have this additional way. So you have four options, four things to consider when you're looking at a parallelogram, when you're looking at a four-sided figure, trying to determine if it's a parallelogram. So what we want to do then in these examples is we need to go through those four things. We need to ask ourselves those questions in order to consider whether these angles or whether these figures are parallelograms. So if we're looking at this figure here, is there enough information to determine if this is a parallelogram? And those are the four questions I need to ask myself. And if I can say yes to any of these four questions, then it is a parallelogram. So question number one, are both pairs of opposite sides congruent? Well, I'm not given any tick marks or any way to determine the length, so based upon question one, I don't know. Okay. Question two, are both pairs of opposite angles equal to each other? Well, in this case, if I look at the opposite angles, I do have 3 tick marks and 3 tick marks, so A and C are congruent. Now, these angles have been divided, but this angle and this one are equal, and this angle and this angle are equal. So if I added these two angles together, it would equal these two angles together, so both pairs of opposite sides are congruent. Opposite angles are congruent. Therefore, this figure is a parallelogram. Okay, so you just need to have these four questions and then just go through each one and see if you can't, by the tick marks, or maybe by some conclusion, if you're told like something is a bisector or something, can you conclude that any of these answers are yes? And if you can, you have a quadrilateral that's a parallelogram. So let's look at this figure here. Is this figure a quadrilateral? Are both pairs of opposite sides congruent to each other? These opposite sides are not congruent, so the answer is no. Are both pairs of opposite angles congruent? Well, I'm not given any information about the angles, so I'd have to say no. Do the diagonals bisect each other? Well, diagonals aren't drawn, and if I draw them, I don't know if they cut each other in half or not, so I can't say yes to that. Is one pair of opposite sides both parallel and congruent? Well, those are not congruent. These are not congruent. So the answer to all four of these questions is no, so this figure is not a parallelogram. So let's do a few more examples, and again, really the whole lesson comes down to these four questions. If you know these four questions, then you're in good shape. So for number 7 here, again, I want to go through my questions. Are both pairs of opposite sides congruent? Well, these are congruent to each other, and these are congruent to each other, so the answer to question 1 is yes. Therefore, number 7 here must be a parallelogram. And my explanation would be this answer to this question is yes. In other words, my answer would be yes, this is a parallelogram because both pairs of opposite sides are congruent. All right, let's look at number 8. Again, I could kind of look at the figure and know, but let's go through 4 questions. Are both pairs of opposite sides congruent? There aren't any tick marks on the side, so there's no way to tell. Are both pairs of opposite angles congruent? There aren't any tick marks on the angles, so there's no way to tell. Do the diagonals bisect each other? Now here's where you have to be careful. This diagonal is being cut in half by this one, and the tick marks show me this. However, this, I don't know if it's being cut in half by this one or not. There aren't any tick marks, and I can't make the assumption. So the answer to that is no, I don't. At best, I don't know. Then the 4th question, is one pair of opposite sides both parallel and congruent? And here, the opposite sides again aren't marked in any way, so there's no way for me to know. So this figure is not a parallelogram, and the explanation is it does not meet any of the 4 conditions. Okay. Number 9 then. We can kind of skip. We notice that the angles are the one that's marked, so let's look at the question about angles. Are both pairs of opposite angles congruent? These opposites are congruent by the tick marks. These opposites are congruent by the tick marks. So the answer to number 9 is yes, the figure is a parallelogram. The reason, because both pairs of opposite angles are congruent. Okay, so that's lesson 6.3. How do you prove a quadrilateral is a parallelogram?